Hi. Over the last 1 year, we have seen an exponential increase in the popularity of generative AI models such as ChatGPT or Gemini amongst people, basically. Surprisingly, though, business uptake of this technology has been slow and it's been mostly exploratory in the form of pilot projects. There are various reasons for this, and one of reasons for this, and one of the technologies that we hear a lot about, which will actually facilitate the use of generative AI for businesses, is RAG. RAG is an acronym for Retrieval Augmented Generation, and this is something you must have been hearing of used a lot in the context of models such as generative AI and ChatGPT. So what is RAG? When do we use it and how do we use it? In this video, I'm going to be explaining this cutting edge technology so that you understand what it is and when and how it is used. All the explanations here will be purely intuitive and geared to the business user rather than a more technical angle. Hi, I'm Shelley, a researcher and professor in the area of artificial intelligence from the management perspective. This is my YouTube channel, AI Economics, where I talked about the latest developments in AI and decode what they mean for business. If you're interested in this area, please do consider subscribing to my channel, AI Economics. And also please like this video as it helps with the algorithm. And hit the bell icon for updates on new videos as I release them. What is RAG, or Retrieval Augmented Generation? RAG needs to be understood in the context of the larger space of large language models, or LLMs, where it is to be applied. To understand what is RAG, we need to understand at a high level what is an LLM such as ChatGPT, how does it function, and what is the gap that RAG kind of comes in and plugs, so to speak. So what is the base problem? ChatGPT or Bard are great. They understand what you type in and generate great responses. But if you're a business looking to use them, then how do you deploy them? Let's walk through a very common use case relevant for most businesses. A common use case might be a chatbot to answer questions, for example, on your company's HR policies. Now, this is useful both for the employees who would then have answers being given to them as and when they need them, and busy HR executives get to save their time. Another application might be things like a financial company using a customer-facing chatbot for answering questions or making recommendations on its products and services. Now, this is one application which requires the application to be 100% reliable and accurate. So what are the key issues with large language models from a corporate perspective? They kind of fall into two broad buckets. The first bucket is data quality. ChatGPT and Gemini are giant models that are trained on hundreds of gigabytes of data. This is all public data coming from the Common Crawl, which is basically all your free websites, your Reddit forums, your Wikipedias, etc. According to some estimates, ChatGPT was trained on approximately 570 gigabytes of data. The size of the ChatGPT model is approximately 175 billion parameters. It's a huge model, and Gemini is an even bigger model. As you can imagine, it's impossible to check and curate a data set of this size for accuracy. Though obviously both Google and OpenAI and anyone else who is in the LLM business, so to speak, do make an attempt to select and clean the data. The second issue that pops up is data privacy. A challenge for businesses looking to use ChatGPT for their processes is that of how to make the model use and respond basis of data which is specific to the product or company to their company, and which is basically private. And the second thing is how to ensure that everyone else doesn't have access to your data. These are two very critical issues. And I would say the second issue is even more important than the first, because companies are very, really value their data and would not at all be willing to give it up to other people. How would a model deployment as a chatbot work? In this slide, I have visualized the very broad process in a very simplistic way. Let's think of the LLM as being this large cloud that you can see over here. And this is your HR chatbot application. This is a person who is keying in a query which they are asking. For example, the query might be, how many days of PL am I entitled to? This query then goes to the HR chatbot. The chatbot then sends the query to the ChatGPT or Gemini large language model. The large language model then generates an answer basis of what it has been trained on. And it comes back with an answer such as 38 to 40 days. Now, how does the large language model actually come up with this answer? It may have seen this number. I mean, for example, I picturized it here. For example, it might have seen a Reddit forum discussing, having a discussion on privileged leave being 40 days. And in another website, it might have seen a figure such as 23 days. And yet in another website, maybe Wikipedia, it might have seen a number such as 37. So overall, on the basis of this, maybe as an average, it will generate an answer of 38 to 40. Unfortunately, this is not correct, because obviously the LLM is not accessing your company's specific HR policies. It is just referring to the kind of training data that it has had access to, and on the basis of that, it is generating a response, which may then seem inaccurate. In the last slide, I discussed what was the core problem with a chatbot application using a pre-trained LLM model. It does not have access to your company's private data. So there are various ways of getting around this. The first method is to fine-tune your LLM on HR documents of the company. Now, fine-tuning is when we train the last few layers of a large language model with domain-specific data. That is to say, your your HR policy corpus, basically. This enables the model to overlay its language understanding. So, I mean, let's think of it this way, that suppose the model has 1,000 layers. Then essentially what fine-tuning would do is probably train the last few layers, maybe the last 5 or 10 layers. So 990 layers would be pre-trained layers, which would essentially represent the linguistic understanding capabilities of the model. And the last 10 layers would be then retrained on the HR corpus of the company. And so that it acquires a certain amount of domain expertise on the model, for the model. Fine-tuning is a computationally expensive process. It can be both expensive and slow, and therefore is something which can be done as a one-time activity, but it is definitely not something where you would definitely not make use of this solution when, for example, for data which is likely to change frequently, which happens very frequently with HR policies, which are updated virtually every quarter. Fine-tuning requires a lot of computational resources. It requires it would require a major budget on the cloud if it is going to be trained on the cloud. It requires very highly trained experts who are able to actually manage the process. So in all, fine-tuning can be a complex and difficult operation, and not necessarily, certainly not something to be done for a small application like a chatbot. The other solution is what we have been referencing of in the beginning of this PPT, which is the Retrieval Augmented Generation, or RAG, and that's what we are going to get to now. Okay, so on this slide, I have tried to visualize what the RAG process would look like simply. It doesn't look very simple and it does look a little complex, but let me just explain it. Okay, first thing is we start off with what is our HR document corpus, which is basically this over here. These documents are basically processed into they undergo similar processing to the kind of processing that happens to data for a large language model. Basically, they get processed for a natural language processing, and it is then stored in what this database, which we can also, for the more technically inclined among you, call a vector database. Now let's understand what happens to a user. A user has a query. For example, how many days of privilege leave do I have? This then goes into a smart retrieval system. What essentially, as part of smart retrieval, the all the documents that are similar to this query are extracted from this database. So anything related to privilege leave will therefore be extracted and sent upwards to the smart retrieval system. So then the query, which was how many days of privilege leave do I have, plus all the retrieved data pertaining to privilege leave in the company's HR corpus, is then sent to the large language model or ChatGPT for further processing. Basis of these two, ChatGPT then comes up with an answer which is hopefully correct, because it is based on the company's HR policy documents. How does this work essentially? Essentially, this methodology is actually quite a smart way of avoiding the whole lengthy fine-tuning process, which is basically very computationally expensive and slow, and at the same time it leverages the advanced linguistic capabilities of ChatGPT by providing it all the extra information as context, or as context to the query. So this is sort of like extra information related to the query which is being provided to ChatGPT. ChatGPT reads the query, reads all the extra information, and then uses its linguistic capabilities and understanding to generate the appropriate answer. This is a technique which is very state of the art and is being actively developed as we speak, and is one of the most promising ways in which we can expect much greater corporate usage. It has the advantage of keeping corporate data private, because it's kept in this private database, which is a vector database, which is private essentially. It does not get shared with ChatGPT except in snippets, the retrieved snippets. The second thing is it manages to use this company data to make sure that the correct response is given. So I think both the challenges which were there for corporate data are addressed by this retrieval augmented generation methodology. This is a technology which has been developed by multiple people in the open source framework. So there's no one company, although Meta, I believe, has been the one which has come up with a fairly major approach. How is RAG to be implemented? There is no one single RAG library for organizational use. There are multiple players out there. I'll cover both the open source and the commercial solutions. In the open source world, we have LLMware as the basic library, which is extremely user-friendly, has an active open source community, and is sort of the go-to library for people who or companies which are new to RAG and retrieval augmented generation process and would just like to do an experiment. So it's ideal for basic piloting and small experiments. Within the open source, you also have more advanced libraries. Verba and Neum are two advanced libraries which are for more advanced users. They have efficient retrievable and scalability for handling large data sets. They can also do performance optimization. They are extremely flexible solutions which can allow a lot of customization and tailoring to specific enterprise needs. The con for Verba and Neum is that they do require you to have a fairly expert team in place to be able to leverage them. Now, coming to commercial solutions. Commercial solutions are always easier to use. I mean, the main emphasis of players in this space is a sort of plug and play approach. Pinecone is a cloud-based provider, which is a cloud-based approach, and it simplifies deployment and management. It's extremely attractive for organizations which are looking for a managed solution and want to avoid any infrastructure setup, etc. Cohere is another company which is providing pre-trained models and tools which are designed to do tasks such as Q&A and text generation, and these are off-the-shelf models. So, I mean, you have both. You have open source and you have commercial solutions. Which solution an organization opt for very much depends upon its requirements, its journey, and the complexity of the task. If you're just starting out and want to run a small experiment, then probably LLMware is your best bet. Verba and Neum are useful if you have got a team an expert team in place, and they are able to then leverage this for more advanced use cases. If you want plug and play solutions, then the commercial solutions definitely offer that capability. I hope you found this video engaging. Please hit the like button as it helps the algorithm. Also, please subscribe to my channel AI Economics and hit the bell icon to be notified about new videos. I hope this has helped you understand RAG and how it can be deployed in the corporate context. Please do look out for new videos from me, which I will be releasing at a regular interval.